This is for Year 11 Methods, Exercise 3K Question 1. So we've got a farmer who has 60 meters of fencing, with which to construct 3 sides of a rectangular yard connected to an existing fence. And we know that the width of the yard is X, and area side is A. Now, we don't know what the length of the yard is, so we'll just call that Y. And we'll know that this is the width as well. Now, it says write down a rule connecting A and X. Okay, you notice how it doesn't include a Y there? So we've got to first find an expression Y in terms of X, and that's given by using the information about the perimeter, because we know that the addition of all the sides of the constructed fence would be equal to 60. So the perimeter x plus y would equal 60. So 2x plus y must equal 60. I can write that in terms y in terms of x, so make y the subject, and we'll get that expression. Now, the area of our fence is given by xy. Now, I can't sketch a graph as instructed in part B with x times y, because we have 2 variables. That wouldn't make sense. What I can do is put it on terms of x, because we've got an expression for y in terms of x. So I sub that in, 60 minus 2x, and we've got an expression in terms of x only, which is good. I can simplify that expression further and take a factor of 2 out, so we get 30 minus x, like that. And that will be our equation for the area in terms of x, which is what we're after. So we have no y's there. Part B, it says sketch the graph A against x. So with real life problems, usually we ignore the negative axes for both, because a negative area won't make sense and a negative length won't make sense. So that's why we only keep the positive side. If we look at this equation again, by using null factor law, we know that we have x-intercepts at x equals 0 and x equals 30. So we know that 0 and 30 will be where the graph cuts the x-axis. Now, if I expand this, that times that will be a negative x squared term, wouldn't it? So it will be a negative quadratic. So we know the shape will roughly look like that. So I can draw confidently that our shape will look like that. Now, to get the maximum area for this graph, we need to first sub in to find a turning point. So we know the turning point is in between the 2 x-intercepts, since it's symmetrical. So we know that the turning point, the x-coordinate of the turning point would be in between 0 and 30, which has to be 15. So to get the maximum area, so the corresponding maximum area, we need to sub in 15 into our equation. So that would be 30 on 30 minus x, which is 15. 30 minus 15 is 15. 30 times 15. So if you work that out on, can't do that on top of my head, just do it quickly on the calculator, times 450. So the area would be 450. So this will be 15, 450. So your max area occurs when x equals 15 meters, and max area is 450 meters squared. Yeah, it's a question, and we've drawn the graph, which we've done for part B.